Another Gauss-Jordan elimination. Let's write the augmented matrix. Notice that there's no x in the final equation. We can cancel out this, so that there will just be this 1 in this column by taking negative 4 times the second row, adding it to the first row. So negative 4 times negative 5 is 20, plus the negative 1 is positive 19. Negative 4 times 4 is negative 16, plus that is negative 21. Negative 4 times that is 60, plus that is 78. Well, this is not as pretty as I would want it to be, but it still is going to work. What I can do now, if I focus on the first and the third rows, I'm gonna take a third of that third row because those are all multiples of 3. Now, I can either cancel this out or this out. It's not really easier to do one or the other. Let's multiply by negative 19. It's just important that we're consistent. Negative 19 times R3 plus R1, put that in R1. So this is going to be 0. Negative 19 times 1 plus 19 is 0. Negative 19 times negative 1 is going to be positive 19. Minus 21 is negative 2. Negative 19 times 4 is negative 76, plus the 78 is going to be positive 2. Oh good, things worked out. Now we pretty much have this. We can divide by negative 2. Now it is worth mentioning that we can do more than one row operation at a time if we're comfortable with that. We're not always going to want to do that because you open yourself up to more opportunities to make a mistake. But it's certainly allowed. It's just a little dangerous in terms of notating everything safely. Add this to R3. Now we have Z and Y. So here's going to be an example where I can do multiple row operations at a time. I'm going to add 5 times this to this, 5 times row 3 to the second row, and negative 4 times the first row to the second row at the same time. So I'm going to take 5 times row 3, negative 4 times row 1, and this is me trying to go a little faster than normal, and add that all to row 2. This is allowed. It's not technically what you're supposed to do, but as long as this can be done by adding negative 4 times R1 to it and then adding 5 times R3 to it, so it still gives us the same result. 0, 0, 1, negative 1, 1, 0, 0, and then we have to do this out for this last one. 5 times R3, so 15, minus So that's, let me write that down. 15. Negative 4 times R1, so that's positive 4, plus R2, that's minus 15. So that ends up with 4, and then 0, 1, 0, 3. So what that gives us, this is not technically in reduced row echelon form. We can reorder the rows to get that, but x equals negative 1, sorry, z equals negative 1. That's what the first equation says. X equals 4, and y equals 3. Those are what those three rows are all telling us. So in other words, the point is 4, 3, negative 1.